With the uncertainty of snow days and things like that, I thought I would create a video for each chapter to kind of review what we need to do for the final exam. Hopefully, this will make it easier for you guys to review for the final exam and make sure you're ready for it when it comes up. I'm going to fill in stuff as we go. I'm going to go chapter by chapter, and hopefully you guys can get a better understanding and feel more confident going into the final exam. I'm going to try to go over as much of this in class as well, but I thought I should cover my bases and make sure it's accessible to everybody regardless of the day or whatever. Okay, so just some quick definitions here. You might want to go ahead and pause the video because you do need to fill this in. It's going to be a grade, so make sure that you fill all this in. But it's going to be a grade for you guys. Descriptive statistics, remember, they are a presentation summarizing data. Inferential statistics is what you use to make predictions on about other aspects of the population. And know that the sample and the population, you definitely need to know the difference between those two. The sample is whatever's being experimented on. Okay. So discrete, there's a difference between discrete and continuous variables as well. Discrete variables assume that all values can be counted, and continuous has an infinite number of values. So you cannot count those. All right. Now let's talk about levels of measurement. You have to know the difference between nominal, ordinal, interval, ratio. Okay. Now nominal is just categories, right? When we're talking about hair color, eye color, race, or religion. Ordinal is when you're putting things into categories, but the precise differences don't exist. So like when you're doing first, second, and third place in a race, or if you're doing A, B, C, D, or F. Please try not to overthink this, okay? An interval ranks data between, there's no meaningful zero. So remember, the biggest thing for interval is usually temperature. In fact, that's pretty much all the examples that we use. And the interval, there's no true meaningful zero. So, and for example, if you say it's 0 degrees outside, that doesn't mean there's no temperature, right? Ratio is it is like interval, but there is a true zero. So if we're talking about height, weight, time, salary, age, for instance, how many pounds did Mrs. Pettit lose over winter break? That would be 0. 0 has a true zero. It's a meaningful zero. Okay? And then explain the difference between observational study and an experiment. The biggest thing I want you to get out of an experiment is that an actual treatment is applied to the sample. Okay? A observational study doesn't apply treatments. It's just, okay, this room of kids, we're going to watch them. They're done a lot in education. Observations of all girl classrooms, all male classrooms, and then co-ed classrooms. That was a big thing. So that's something to take with you. All right. So those are all the definitions that you would need for chapter 1. I might actually go to chapter 2 if we have enough time today, if I've gone through enough. Okay, so classify each not as nominal, ordinal, interval, or ratio. Okay, so remember, nominal is category. So let's do. So nominal is category. Okay, so pages in the 25 best-selling mystery novels. We have interval or ratio. This would definitely be ratio because there's a true zero. So if we have 0 pages, that means there are no pages in the book. So that is true. Rankings of golfers in a tournament. That's easy, ordinal level, okay? Temperatures inside 10 pizza ovens. This is horrible. Sorry, guys. Hold on. Okay, so sorry. That's weird. So, pages in 25 best-selling mystery novels, that would be ratio. Having technical difficulties today. Rankings is ordinal. All right. This is interval. Remember, no true zero. Weights of selected cell phones. Any weight would be ratio as well because there is a true zero. Salaries of the coaches in the NFL, that's also a ratio. I guess someone can earn $0. Times required to complete a chess game, that is also ratio. Ratings of textbooks, that is ordinal because we're rating them, but we're not putting them in a category. Number of amps delivered by any battery chargers, I'm assuming that's ratio as well. Ages of children in a daycare center, there is ages, very easy. Categories of magazines, categories easy, nominal. Okay. Qualitative or quantitative marital status would be qualitative. And that is nominal. Nominal, remember that nominal and ordinal can both be categorical. Or as we talk about qualitative. All right. Time it takes to run a marathon, that's quantitative. Anytime you're talking really about a number, it's usually quantitative. Weights of lobsters is quantitative. Colors of automobiles, colors are always qualitative. Those are categories. Ounces of ice cream, quantitative. Capacity, quantitative. And ages are also quantitative. Now, I named the two areas of statistics that was inferential and descriptive, Make sure that you define those again. Okay. So moving on. There you are. Okay. Moving on to the next page. Let's talk about the methods of sampling. I think we talked about, let me take a look at sampling methods. I think I knew I was missing something. Nope. Hmm. Okay, so let's talk about in a large, okay, random, systematic, stratified, or cluster. So some key things about cluster sampling, guys, is it usually has to deal with location. Clusters are chosen randomly. But everyone in the cluster is experimented on, right? A systematic is usually when you're doing like every nth, like every third, every fourth, every fifth. So I would say every nth person or subject. Stratified. Stratified is when you're putting them into categories. And then you're taking a random sample from each category. Okay, so let's take a look at this. In a large school district, all teachers from the buildings are interviewed to determine whether they believe the students have less homework now than they do. All teachers from 2 buildings are interviewed to determine whether they believe the students have less homework to do now than in the previous year. So all the teachers from 2 buildings, so that would tell me that is a cluster. Okay, every 7th customer, that is systematic. All right. Nursing supervisors are selected using random numbers. This is also just random. Every 100th hamburger manufactured is checked to determine its fat content. That would be systematic. Mail carriers of a large city are divided into 4 groups according to gender and according to whether they like to ride or walk in their routes. Then 10 are selected from each group and interviewed. Okay, so that is a straight up stratified because there were categories. Okay, so hopefully that should help you. So let's move on to the next one. Let's see which studies are observation or experimental. Okay, subjects were randomly assigned into 2 groups, and one group was given an herb, the other a placebo. After 6 months, the number of respiratory tract infections in each group were compared. That is an experiment because one, the treatment was the herb or placebo. So a researcher stood at a busy intersection to see the color of automobile that a person drives is related to running red lights. That is an observation. He's not doing anything. He's not doing anything to the cars. He's just seeing which ones run the red lights. So a researcher finds that people who are more hostile have higher total cholesterol levels than those who are less hostile. What's the treatment? There is no treatment. So again, that is an observational study. You can't give a treatment of hostility. So subjects are randomly assigned into 4 groups. Each group is placed in one of 4 special diets: low-fat diet, a high-fat diet, a combination, yada yada. The diets are the treatment. So this is an experiment. Okay, let's move on. So one of the things that you guys need to be able to do, and we just discussed this, is what is the difference between, is a study biased or not? So one of the things you have to do is recognize whether or not a study is biased and why. So let's read this. Caffeine and health. In the 1980s, a study linked coffee to a higher risk of heart disease and pancreatic cancer. In the early 1990s, studies showed that drinking coffee posed minimal health threats. However, in 1994, a study showed that pregnant women who drank 3 or more cups of tea daily may be at risk for spontaneous abortion. In 1998, a study claimed that women who drank more than half a cup of caffeinated tea every day may actually increase their fertility. In 1998, a study showed that over a lifetime, a few extra cups of coffee a day can raise blood pressure, heart rate, and stress. Bottom line, is it good for you or bad? Suggest some reasons why these studies appear to be conflicting. Okay, so there could be sample bias depending on who the women who were treated, what type of women were treated, who were studied in each one of these things. There could be lack of a control. Remember, each good experiment has to have a control group, right? Maybe the sample wasn't random, or it needs to have enough replication, meaning that it needs to go to enough people to apply to the population. So these are all things that could have been wrong with this sample. Number of ads on a 1-hour television show is what type of data? It is not ratio, it's ratio, because there's not interval, I mean. Okay? So moving on. Okay? So researcher divided subjects into 2 groups according to gender, and then selected members from each group of her sample. This is stratified. The strata is the gender. Okay, I'm going to go ahead and stop right there at chapter 1. But hopefully that gets you guys going for this. But this is chapter 1 for the exam review. Remember, you have several more to do, but hopefully that should help you guys. Yeah, because that was 20 minutes. So thanks for watching. Talk to you later.